Right, let us go on with analytical geometry. I was going to do one more. I will make that one up in a little bit. Please remember, a lot of these are going to be into the test and exam preparation section, where we're going to work through quite a number of these guys, okay? All right, let's have a look at analytical geometry, okay? What do we mean by analytical geometry? Well, it's actually in the name. Geometry, we are now putting together algebra, and we're putting together geometry, okay? Remember, trigonometry was the third leg of all of this. We're going to be putting algebra and essentially graphs and geometry together now. Well, if you remember, the first thing that we did is we've got the equations of graphs. So we can work out which way they're going. We can plot them. We can actually work out lengths of lines between two graphs cutting, can't we? But now we want to go a little step further, and we want to say to ourselves, okay, if that's the case, sorry, let me just adjust that down, there we go. If that's the case, all right, we want to say, well, what is the length of a line between A and B? All right. Now, if you remember, we had, let us say we've got the coordinates -1 and -1 over here, and the coordinates of B are 6 and 4, like that. Okay. Which means that essentially the axes are sort of down there, but you know what I'm doing, X and Y. Okay. So we want to know what is the length of the line AB. How long is it on the slope now? Remember what I said. Well, first of all, we said we can work out what that length is, can't we? That's delta Y. And we can work out just to do what we did before, delta X. We can work out that length there, and we can work out that difference in height. Well, that straight away says to you, hang on, because that's a right angle, because that's 90 degrees, remember? So therefore is equal to delta X squared plus delta Y squared, and let me put them in brackets like that. Okay, well, what is delta X? Well, delta X is going to be X2 minus X1, isn't it? Squared plus Y2 minus Y1. It's this height here, that height there. Correct? And if that's a minus, it's going to be additive. And therefore AB is going to be equal to the square root of X2 minus X1 squared plus Y2 minus Y1 squared. That is called the length formula. Okay, and yes, you can derive it. Okay, quite straightforward, like I just did. Remember, in all of this analytical geometry and all of this, you can always go to the good old-fashioned, where are we again? The good old-fashioned triangle. You can work out that height, you can work out that length, okay? Because once you've plotted it, just roughly, you can kind of see it straight away. It's evident, isn't it? So what are you going to do? You can work it out, all right? So, let's have a look. Let's go back to our example, right? How high is this? Well, this is 6, and that is up at 4. This is down at -1 over there, so what is the length delta Y? Delta Y is 6 up, 4 up and 1 down, so that total length is 5. Delta X is going to be 6 and another 1. How long is that? It's 6 from there to there and 1 backwards, so it's 7. So what is the length of AB then? Well, AB, the length AB is going to be equal to the square root of 6 of 7 squared. Let me just get my numbers again. Okay, that's 5 squared plus 7 squared. All right. It's going to be 5 squared plus 7 squared is the square root of 25 plus 49 is going to be the square root of 74 units. Okay? And or, remember, that is if they tell you to leave it in the surd form. Or, and they could say, to 2 decimal places, it's going to be equal to 74 to the power of 0.5 is 8.6 units long. Okay? 2 decimal places, 8.60. Okay, right. So we now know that we can derive it. Okay? Now, guys, it doesn't matter, but all I say to you is if you're doing lengths, okay, of various lines on shapes, take your pencil and label x1, x2, y2, y1. Do the subtractions according to the formula and put them in brackets, okay, because of the negative signs, all right? Please label them, and then when you've done with those 2 points, you can just quickly erase the pencil and maybe use that point with another point, okay, and relabel it, okay, because they ask you to work out quite a few lengths, okay? Let us look at an example that we've got here. How do we approach the problem? Okay, first of all, step 1. This is how we solve problem solving in analytical, okay? Step 1, okay, always draw it. Draw it using a rough scale, okay? So you use a rough scale to draw it. In other words, like I said before, use the ruled lines sort of more or less, okay? Try and get it because it's giving you an indication of the directions, positive, negatives, and it's kind of showing you the shapes that you should be looking for, okay? Right. So we say do that, okay? Use the lines of the page. The second, step 2. Once again, guess what? Read, read, and read it again. Why? Because the information is given in there. They will, for example, tell you that it is an isosceles triangle, or it is a rhombus, or a kite, or something is parallel to something. There is information given in there. That is your starting point, okay? And you have to use that information, okay? Time and time again in this, I say to the guys, did you read the question? And they look at it and they say, oh, there it is. So when you're doing it, I know exams are pressure, I know it's speed, but read the question, okay? Take your pen and go, parallelogram, highlight it, because you need to know the properties of all of these shapes in this part of the syllabus. It is no longer just a necessary to do it geometrically. We're now going to be doing it analytically. All right. Right. So the next, it keeps twisting itself in. The next one is to say, okay, what are we going to do? Okay. You put the information onto a sketch. Let us say they give us something like this. All right. Just for argument's sake. All right. They give us a drawing and they give us a point here. A is -2 and 0. Okay, -1, -2, and 0. And they say that's A. B, they say to us, is 0 and 4. So we go 1, 2, 3, 4. Okay, so we say that is 0 and 4. Okay, so can you see we've got that point and this point now? There we go. Next one is 4 and 2. 1, 2, 4, and 1, 2, right? So that's 4, 2, right? And that is point C, okay? You can sort of see this taking shape. The last point is 2 and -2, 2 and 1, 2. Okay, then they say, right, there's point A, B, C, and point D, and then you'd complete that like that. And they say to us, it looks like, look at it. Okay, let's say question 1, calculate the length of AC. So they want length of AC first of all. First of all, I say, right, let me write down the thingy. It's going to be my length formula, y2 minus y1 squared plus x2 minus x1 all squared. So let me go to my thingies and write it down. I am looking at length AC, right? So I go, you are x2, y2. You are x1, y1. So let me input into my formula. It is the square root of y2 is 2 minus, 0 squared plus x2 is 4 minus 2 squared. Can you see what I did there? Please, can you see, because we're subtracting, there's a possibility of a minus. So input in brackets, right? When you've got a minus sign, put them in brackets, because this comes out to be the square root of 6 squared plus 2 squared, which is going to be square root of 40. All right? Or 2 root 10 if you want to simplify. What is the next step? They say find the coordinates of the midpoint of BD. All right? They now want us to find. So we've now found the length. Let's just put in a little thingy here. We now know the length there is root 10. Okay? Now they want us to find the coordinates of the midpoint of BD. So that's a midpoint of BD, isn't it? Okay. Remember, they haven't told us anything about A, B, C, D. Is it a rhombus, a parallelogram, or what it is? We don't know. All right? So we say, okay, the coordinates of the midpoint. X of the midpoint is equal to x1 plus x2 over 2. Y of the midpoint is equal to y1 plus y2 over 2. Right? That's the average, essentially, the average of the x and the average of the y, isn't it? All right? Okay, I haven't covered that in the derivation, but I mean, it's pretty obvious. So the midpoint is 0 plus 2 over 2, which is 1. And this one is going to be 4 plus minus 2 over 2 is going to be 4 minus 2, 2 over 2, which is 1 again. So the coordinates of the midpoint are 1 and 1. Okay? The next, they say, what shape is it? Okay? So, hold on. Let's just go back up. Okay? Can you see? There we go, the coordinates of that. And look, even though I am not accurate, look how close that is to 1 and 1. All right? Just by being rough, you can see, because if I'd have got 1 and 0, I know I'm way out. I've made an error. Okay? So what do? I'm more or less seeing that I'm right. What shape is it? Well, it could be a square or a rhombus, couldn't it? Okay? Well, what do? Okay? They have asked us, what shape is it? Okay? Well, it looks like it could be a square, or it could be a rhombus, couldn't it? Okay? All right? How do we prove a square or a rhombus? Well, for a square, we need a corner at 90 degrees and the length of that equal to the length of the other sides, right? Well, what can we know? We know the length AB and BC are, AB and BC. Let's go and work them out, all right? So you work out the lengths AB and BC, okay? And let's have a look. Length of BC, lengths of AD, lengths of whatever. Let's go and work out some of the lengths, shall we? All right. Length of AB is equal to, and what you do here is the square root of 0 minus 2 all squared plus 4 minus 0 squared. Comes out to be root 20. All right. The length of DC is the square root of 2 minus 2 squared plus minus 2 minus 0 squared. Comes out to be root 20. Okay. And if you work out the other side, you'll find they're all the same length. which now means we're either a square or a rhombus. The parallelogram is out the door. Well, it's a special case anyway. But if we work out all the other sides, we find that they are exactly the same length, right? So now, the next thing we've got to do is we need to check if one of these corners here, okay, let's just go, if one of the corners, okay, if we can prove, let's have a look here. No, let's change it to red. If I can show that's 90 degrees, okay, then what? Then I know we've already shown that equals that equals that equals that. If that's 90 degrees, then it means we've got a square. It looks like a square, but let's have a look and see. Okay, well, what do? I say this, don't I? How do I prove that something is 90 degrees? To prove angle ABC equals 90 degrees. There's two ways. Step one, my first way is I can say, right, hang on, what if I took AB plus, let's just have a look at our diagram again, okay, AB, this side here, plus BC squared, and I square those two and see if it's equal to AC. Then we've got the answer, haven't we? All right. Well, let's have a look. AB plus BC and squared. Let's see what that's equal to. Well, we know this is equal to root 20 squared plus root 20 squared. Okay. That is therefore going to be equal to 20 plus 20, which is equal to 40. What is let me just go back. What is AC's length? Remember we worked out AC earlier? We said the length AC was root 40, remember? Length AC was root 40. But AC is equal to root 40. Therefore, AB squared plus BC squared is equal to AC squared. Therefore, angle ABC is 90 degrees. We work it backwards, don't we? We say to ourselves, hold on a second, guys. If I've worked out lengths, right? If the length of that squared, here we go, the length of this squared plus the length of that squared, if it equals the length of that squared, it means it's a right angle down the bottom here. It's Pythagoras in reverse, is it not? Okay. Well, what is the next way I could have worked it out? Let me think. What else tells me the two lines cross? And here's a big word. Orthogonally. Orthogonally means they cross at 90 degrees. If I take m of 1 times m of 2 and I get minus 1. Remember that? If I take m of 1, m of 2, I multiply and it comes to minus 1, I get that, don't I? So I must then say, all right, let's just try it and see, shall we? Okay. First of all, using the gradients, what is m of AB? Okay, it's going to be 4 minus 0 over 0 minus minus 2, which is 4 over 2, which is 2. Let us look at the gradient BC. Okay, gradient BC is 4 minus 2 over 0 minus minus 4, which is going to be minus a half. Therefore, if I take the gradient of AB times the gradient of BC, I've got 2 times minus a half, which is minus 1. Therefore, AB is orthogonal to BC. So that is using the gradients, all right? So in essence, we've got to remember here that we've also got the fact that we've got to work on it that if the gradients, remember, if m1 times m2 is equal to -1, they are cut each other at 90 degrees. If M1 equals M2, they are parallel. Right? So in analytical geometry, that's essentially the core of it. So a few pointers for it, okay? First of all, okay, if you need to prove 90 degrees, you can either use Pythagoras or you can use orthogonal, okay? Orthogonal gradients. So I take the gradient of this one, gradient of that one, I multiply them together. If I get -1, then it means that I've got a 90 degrees, right? Then the other side is to say to myself, right, I can also use Pythagoras in reverse, can't I? All right. Right. Now, there's one other key little point over here with this guy. If you are given a midpoint, remember the coordinates, x of the midpoint is equal to x1 plus x2 over 2. And y of a midpoint is equal to y2 plus y1 over 2. And what I've got there is I've got a situation of, if I know what the midpoint is, if this is given, okay, and that's given, I can work out that one. If that's given and that's given, I can work out this one, can't we? So if they're looking, and we're going to do one of those in a few secs, okay, we can actually go ahead and work it out, all right? In the next session, what I'm going to do, I'm just going to cut this one because now I've got another long sum that I've got to work through. In the next session, I'm going to work more with these coordinates, these analytical geometry, more with the coordinates, more with the slopes of the lines, okay? So thanks for watching that one. I'll be back in the next session. Cheers. Good luck with this.